Hi guys, my name is Melissa, and in today's video we're going to be talking about factors. So to introduce you guys what factors are associated with a certain number. And so factors of a number n are the numbers that n is divisible by. So for example, if the number that we're talking about is 6, we're going to see what factors the number 6 has. So first, 1 is always a factor of any number, right? And so if we have 1 as a factor, then that eventually means that itself is also a factor. So basically, as a default, any number has two factors, 1 and itself. Then we're looking for other numbers that the number can be divisible by, and that would be 2 and 3. And always for factors, we have factor pairs, because what that means is that since a 6 or any number that we're talking about, if that number is divisible by something, that we have a quotient and a dividend. And so basically, there's always going to be an even number for factors. Like 1 and 6, they're together, and 2 and 3, they're together. So basically, the numbers are going to be 1, 2, 3, and 6. And so before we move on to solving practice problems, I want to make sure that you guys have understood basically the general idea of how to get factors. So I'll be giving you guys 2 minutes each for these types of questions, because I know it's just an introduction to factors. So if you guys do know the answer, you can feel free to skip, but for now I'll be giving you guys 2 minutes to figure out the factors of 18, and then I'll be going over the answers for the factors of 18 after 2 minutes. So the factors of 18 are going to be 1, 2, 3, 6, 9, and 18. And so to check, 1 times 18 is 18, 2 times 9 is 18, and 3 times 6 is 18. And so if you missed any of these, just make sure you guys can think about factor pairs. And so we are going to learn about factor pairs in our next video, but just to give you a heads up, you guys can avoid missing any factors by double checking and seeing if there are two pairs that, when multiplied, result in the number. Now we're going to solve some practice problems to get used to factors. And so we're going to circle all numbers below that are factors of 18. So 1 is a factor of 18. 18 is divisible by 2 because 18 divided by 2 is 9. 18 divided by 3 is 6. So 6 is also going to be a factor. 18 is not divisible by 4, 5, or 7. So these four are going to be factors of 18. Circle all numbers below that are factors of 21. 1 is a factor, 21 is divisible by 3, and that gives us 7, so 7 is also a factor. 21 is not divisible by 5 or 6. 21 is not divisible by 14, and it's not divisible by 42. Now 42 is what we call a multiple of 21, but it's actually not a factor. Circle all numbers below that are factors of 72. So 72 is divisible by 2, and 72 divided by 2 is 36. Not divisible by 5, not divisible by 7, and it is divisible by 9, because that gives us 8, but 8 is not an option here. It is divisible by 24, because it gives us 3, and itself as well. So the next problem says circle on all numbers below that have 5 as a factor. So we're going to see whether these numbers can be divided by 5. So 12 does not have 5 as a factor. 15 is divisible by 5, so it does have 5 as a factor. 30 also has 5 as a factor because it can be divided by 5. 45 as well. Then for the next problem, we're circling all numbers below that have 3 as a factor. So 6 can be divided by 3. 36 can be divided by 3. 45 can also be divided by 3. Circle all numbers below that have 8 as a factor. So 16 can be divided by 8. 32 can be divided by 8. Since 32 divided by 8 is 4. 48 divided by 8 is 6. And 96 divided by 8 is going to be 12. And then for problem number 7, it says, which two numbers are factors of both 41 and 21? So for 41, it's going to be 1, 45. I have to do it in pairs so that I don't forget any. 5 and 9. And before that, we have 3 and 15. And we have 5 and 9. For 21, we have 3 and 7. And 21. So which two numbers are factors of both 45 and 21? We're going to look for ones that overlap, and they're going to be 1 and 3. It's going to be 1 and 3. Now we're going to learn about things called factor pairs, which I briefly talked about. So for factor pairs, basically these are things like, so for example, if we have the number 6, then 6, if we're going to think about 1 is a factor of 6, so 6 divided by 1 is 6. So 1 and 6 are factor pairs. When we divide 6 by 2, we get 3, and so 2 and 3 are factor pairs. So these are what we call factor pairs. And so writing a number's factor in pairs helps us stay organized, and it also helps us prevent missing out any factors. And so it makes finding factors easier and more organized. So we list pairs of numbers that can be multiplied to get 48. So for example, 1 and 48 is a pair, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So what you want to do is you want to start with small numbers and go in order. So does 1 work, does 2 work, 3, 4, 5, 6. So you want to test it in order so that you can really get all the possible factors without missing any. And and this is an exception, and sometimes we have perfect square numbers like 49, where multiplying itself by itself gives that number. For example, for 49, 7 times 7 is 49. And so, in this case, we could have an odd number of factors because we only count 7 once. So for 49, we would say that 1, 7, and 49 are factors of 49. And yeah, so for 10, we have 5 and 5. So we have 5 pairs, so that means we have 10 factors of 48. Yeah. And so we'll look at problem 8. We're listing each of the 4 factor pairs whose product is 30. So again, I like to start with 1, and its factor pair is going to be 30. 2, 15. 3, 10. So 30 is not divisible by 4, so we skip, and we have 5 and 6. And I know that if we do 6, we have 6 and 5, but these two are basically the same thing. So we can stop here for 5 and 6. For problem 9, we're listing each of the 4 factor pairs whose product is 56. Again, we have 1 and 56. Then we have 2 and 28. 56 is not divisible by 3, but for 4 we have 4 and 6. We have 4 and 14. It's not divisible by 5, not divisible by 6. And then we have 7 and 8. Now for the next problem, we're going to list factor pairs whose product is 35. So we have 1 and 35, not divisible by 2, not divisible by 3, not divisible by 4, and then we have 5 times 7. And that's going to be it because the next one we have is 7 times 5, so it's going to be repeated from there. So I'll be giving you guys a minute to figure out what the factors of 54 are before I go over the solutions. For 54, we have 1 and 54, 2 and 27, 3 and 17, 3 and 18, and 6 and 9. And then from there, it's going to be 9 times 6, so it's going to be repetition. And so we have 4 factor pairs. For problem 12, we're going to list factor pairs whose product is 26. So we have 1 and 26, 2 and 13. And then the next one is going to be 13 and 12, so that's also going to be repetition. Then we have, we're listing factor pairs for 40. And now to make sure that we've understood how to solve for factor pairs, I'll give you guys about 1 minute to solve factor pairs of 40. And so there's quite a lot of factor pairs for 40. So I want you guys to consider all of the possibilities before I go over the solution and list out all the factor pairs for confirmation. Whose product is 40, so we have 1 and 40. It's divisible by 2, so 2 and 20. Not divisible by 3. Then we have 4 and 10. Then we have 5 and 8. And then the next is going to be 8 and 5, so it's going to be repeated. So we have 4 factor pairs that we can list. Now, how many of the factors of 42 are odd? Now we're going to write out the factor pairs for 42. We have 1 and 42, 2 and 21, 3 and 14, and 6 and 7. So out of these, we have 4 factor pairs, so we have 8 factors. So ones that are odd, 1, 3, 21, and 7. So we have 4 factors that are odd. And then we're listing all the factors of 48 that are also factors of 30. So I want you guys to try solving 15 on your own. So to give you guys a hint, you guys should list all the factors of 48 and factors of 30 by using factor pairs, and then see which ones overlap to see factors of 48 that are also factors of 30. And so since you guys have to figure out factors of 2 numbers and also compare, I'll give you guys about 4 minutes before I go over the solution. And if you guys are done earlier, you can always feel free to come fast forward until we talk about the solution and explain. But if you guys need more time, again, feel free to pause the video when you need to. So for 48, we have 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. For 30, we have 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So 1 is a factor of both 48 and 30, 2 as well, 3 as well, and then not 4, but we see 6 in both. We see 6 as a factor for both 48 and 30. And yeah, I think that's it. So the factors of 48 that are also factors of 30 are going to be 1, 2, 3, and 6. Now, problem 16 says that Grog draws a rectangle that has side lengths that are whole numbers of inches. The rectangle's area is 52 square inches. How many different heights are possible for Grog's rectangle? So we're basically finding factors. So for 52, we're going to list factor pairs. So 1 and 52, 2 and 26, 4 and 13, and yeah, I think that's it for factor pairs. So 52 has 6 factors, and they can all be possible heights. So possible heights are going to be 1, 2, so all of them are possible heights, and so we have 6 possible heights. For problem 17, Winnie picks a number n. When Winnie divides 59 by n, she gets a remainder of 3. List all possible values of n. And so it says, when Winnie divides 59 by n, she gets a remainder of 3. And so what we can do is we're first gonna, since 59 divided by n has a remainder of 3, we know that n must be divided by 59 minus 3, right? Without the remainder. So without the remainder, it's going to be 56. So 56 divided by n must be divided without any remainders. And so now we're going to look for n by looking for factors of 56. So we're going to write out factor pairs. So we have 8 possible factors because we have 4 factor pairs. And so, but we still need to be careful here because we need to eliminate 1 because 59 can be divided by 1 because 1 is a factor of any number. And then when we divide 59 by 2, it's not giving us a remainder of 3 because it's a special case. And so the only possible answers are the remaining ones, which are 4, 7, 56, 28, 14, and 8. So if you write that in order, it's going to be 4, 7, 8, 14, 28, or 56. And so now I want you guys to solve problem 18 and 19 on your own to make sure that we understood factor pairs correctly. So I want you guys to list factor pairs for 100 and also for 64. And also try, even though we're listing factor pairs, keep in mind that for perfect squares like these, there could be repeated factors, and so think about whether we should count that as one factor or two factors. So I'll give you guys about 3 to 4 minutes and then go over the solutions. Now it says list each of the factor pairs whose product is 100. So we have 1 and 100, 2 and 50, 5 and 20, well, we have 4 and 25, 5 and 20, and 10 and 10. List each of the factor pairs whose product is 64. 1 and 64, 2 and 32, 4 and 16, and 8 times 8. And for this, we can write it as a factor pair, but when we talk about how many factors we have of 64, it's going to be 7 because it's going to be these 6 and 8 because we only count 8 once. Now for 20, it says how many different numbers are factors of 100. Now again, same thing, 10 and 10. The 10 can only be counted once, so we say that there are 9 different factors of 10. 9 different factors of 100. Now for 64, same thing, we say 7 different factors of 64. Now for number 22, it says, explain why every perfect square has an odd number of factors. Now this is because there is always a factor pair involving 2 of the same numbers, right? And that's basically what we call square numbers, or perfect squares. So 7 times 7, 10 times 10. So 100 or 49, those are perfect squares. And that's when we multiply the same number. And so that's why there's an odd number of factors, because we only count that number once. For 23, it says, there are 4 numbers less than 50 that have exactly 3 factors. The smallest of these numbers is 4. What are the other 3? So only perfect squares have an odd number of factors, right? 3 is an odd number, and it's less than 50. So 1 is going to be 49, and the smallest is going to be 4. And 4 is 2 times 2. So we're first going to write out all square numbers, all perfect squares less than 50. So 4 is 2 times 2, so we're going to do 3 times 3, which is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. But then there's 3 factors only. So even though perfect squares have an odd number of factors, it doesn't always mean that they have 3 only. So for 4, the possible squares are 1, 2, and 4. So that would be correct. For 9, the only possible ones are 1, 3, and 9. For 16, though, it can be 1, 2, 4, 8, and 16, so there's more than 3. For 25, again, there's 1 and 5 and 25 only. For 36, there's so many possibilities because we have so many factor pairs, like 2 and 18 and 3 and 12. So 36 does not have only 3 factors. And for 49, we have 1, 7, and 49. Okay, so it says the smallest of these numbers is 4, and so we're looking for the other 3. So it's going to be 9, 25, and 49. Now we have our last problem. Elliot has a room with 100 light switches numbered from 1 to 100. Each light switch is turned off, and Elliot invites 100 friends over and gives each friend a different number from 1 to 100. Friend number 1 flips every switch that is a multiple of 1, so all of them. And then friend number 2 then flips every switch that is a multiple of 2. So multiple of 2, or that number has a factor, and 2 is a factor. Friend 3 flips every multiple of 3, so 3 is a factor. And this continues on until all 100 friends have flipped switches, with friend 100 flipping only the 100th switch. After all flipping, which of the light switches are on? So when a friend flips a light switch, if it's on, it turns off. If it was off, it turns on. And so for problem 24, all the switches are first initially off. And so we know that every friend flips the switches whose numbers are multiples of his or her number. So for example, the factors of 15 are going to be 1, 3, 5, and 15. So switch 15 is going to be flipped by friends 1, friends 3, friend 5, and friend 15, and so on. And so we're going to figure out whether a switch ends up off or on by knowing about the switch's number of factors. So after all the flipping, which light switches are on? So only the switches numbered with perfect squares have an odd number of factors. And so for other numbers, so only the switches numbered with perfect squares have an odd number of factors. And so only the switches numbered with perfect squares will be flipped an odd number of times and will ultimately end up with on, because it started with off, and flipping an odd number of times is going to make it the opposite, so it's going to be on. And every other switch that's not a perfect square is going to have even factors, and so eventually they're going to return back to its off state, the same as it started. So only the switches numbered with perfect squares are going to be turned on eventually. So that's going to be 1, 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. And 10 times 10, 100. So these ones are going to be the switches that are going to be on at the end. And yeah, that's the end of our lesson today, and I hope you guys have a great day today and have had a fun lesson time, and I'll see you guys all in the next video. Bye!